Good day to all the Form 4 and Form 5 students. The effect of data changes on dispersion is a topic for Form 4 KSSM student and is also for Form 5 KBSM student. So for Form 5 student, this is additional maths under statistics. Okay, meaning that the Form 4 student now have to study additional maths syllabus. So there are two parts for this topic. Okay, one is determine the effect of data changes on dispersion based on value of measure of dispersion. The other one is graphical representation. So for KSSM Form 4 student, you need to learn two parts. But for Form 5 student, you just focus on the value of measure of dispersion. The graphical representation is not in the syllabus for additional maths. Effect of data changes on dispersion. What is the effect of data changes on dispersion? So the data changes included the following cases. A. Each data is added or subtracted by a constant uniformly. So add meaning that you are add a positive number. Okay, subtracted means I can add a negative number. So it's actually concept wise is the same. For B, each data is multiplied or divided by a constant uniformly. So multiply, let's say you multiply by 2, okay, and divide by 2. Multiply by 2 divided by 2 is different. But multiply by 2, okay, can be expressed into divide by 1 over 2. Do you understand me? Okay, for part C, the existence of outlier or extreme values in the set of data, and the part D, certain values are removed from a set of data or added. So for this first part of the video, we'll just focus on A and B, okay? Because this topic is quite long, so I divided into two parts. So please follow my second video after this. Okay, there are 4 types of data changes. Okay, include the following cases. First one is each data is added or subtracted by a constant uniformly. Case 2 is each data is multiplied or divided by a constant uniformly. And the third case is existence of outliers or extreme values. And the fourth case is certain values are removed from the set of data or maybe added into the set of data. Now we want to find out what are the effects on the measure of dispersion when each data is changing by adding or subtracting a constant. Okay, let's say we have data 5, 8, 3, 4, 1. So if each value of set of data is added 5, let's say added 5. So the data now become 10, 13, 8, 9, 6, the new data. What will happen to the measure of dispersion for this set of data? Example, what is the range? What is the interquartile range? What is the variance? What is the standard deviation for the new set of data? So first of all, we will arrange the data in order. This is the original data. We will arrange in order. We find the range, 8 minus 1, 7. Then we will find the interquartile range. Interquartile range, we will take the third quartile minus the first quartile. So since median is 4, so the third quartile should be in between 5 and 8. So we will take 5 plus 8 divided by 2. Okay, so this is third quartile, 6.5. Okay, then we have to find the first quartile. First quartile is the data to the left of median. So it's 1 plus 3 divided by 2. 4 divided by 2, so it's 2. So that means interquartile range is 6.5 minus 2, equivalent to 4.5. And then we need to find mean. Mean we sum up all the data. Okay, 5 plus 8 plus 3 plus 4 plus 1 divided by 5. So mean is 4.2. And we have to find the variance. We find sum of data square. Okay, so divided by 5 minus the mean square. So the variance is 5.36. And we just square root 5.36, we get 2.3152, which is the standard deviation. These are the measure of dispersion for original data. Okay. Now we want to plus 5 for the original data. We want to see the changes for the measure of dispersion. So the new data now is 6, 8, 9, 10, 13. So the range is 13 minus 6, the maximum minus the lowest, 7. Interquartile range, we will minus Q3 minus Q1, so it's 4.5. Mean is we will sum up everything, then we divide by 5, it's 9.2. And the variance, we will sum of the data square divided by 5 minus mean square. Is measure of dispersion remain unchanged when each data is added or subtracted by a constant. Okay, the constant that you add is 5. So mean is not a measure of dispersion, as it cannot show the dispersion of data. So if we do comparison, all the measure of dispersion before and after remain unchanged except mean. Let's study this example. It initially have 5, 8, 3, 4, 1. Now you times 2 for all the data. So it becomes 10, 16, 6, 8, 2. Then what happened to the measure of dispersion, such as range, interquartile range, variance, and standard deviation for the set of data now? Let's discuss. So starting, we arrange in order. We find the range, find the interquartile range, find mean, variance, and standard deviation. Okay, then we multiply by 2. Okay, the data now become 10, 16, 6, 8, 2. Arrange in order 2, 6, 8, 10, 16. Now the range become 14. Okay, so if you times 2, now the range become 14. So for the new set of data, after multiply by 2, we find range 16 minus 2, 14. Then interquartile range is Q3 minus Q1. So it's 13 minus 4 equal to 9. Okay, so then we will find the mean. Mean is sum up all the data divided by 5, which is equal to 8.4. Variance is you have to sum of data square divided by 5 minus mean square. So it's 21.44. And standard deviation is square root of 21.44, 4.6303. So now we want to do comparison before times 2 with after times 2. So it seems like range become 2 times. Okay, interquartile range also become 2 times. Mean also times 2 followed by times 2. Okay, variance become times 4, 21.44 times 2 square. Okay, remember variance must be square. Okay, standard deviation is times 2 also, right? Okay, so there is a changes, okay, after multiply by a constant. So when each value of a set of data is multiplied by a constant k, new range become k times original range. New interquartile range become k times original interquartile range. New standard deviation become k times original standard deviation. And new variance become k squared times original variance. Okay, so you can observe for new range, new interquartile range, and deviation times k. But variance you have to times k squared. Next, we'll discuss what are the effects of the measure of dispersion when each value of a set of data. Now let's study what happens if we change the data by dividing a constant. So let's say you have 58341. So each data you divide by 2, so it becomes 2.5, 4, 1.5, 2, and 0.5. So we want to study the range, interquartile range, variance, and standard deviation. Okay, these are the original data, original range, interquartile range, mean, variance, standard deviation. Now we divide by 2 for the data. So the data now become 2.5, 4, 1.5, and 2. Then we arrange in order. So the range now is 4 minus 0.5 equal to 3.5. Interquartile range is equal to Q3 minus Q1, which is 3.25 minus 1. Okay, so interquartile range is 2.25. Okay, mean is sum of all the data divided by 5, which is 2.1. Okay, variance with sum of all the data square, and then divided by 5 minus 2.1 square. So the variance is 1.34. Then in order to get standard deviation, we square root the variance, which is 1.1576. So it seems like after divided by 2, the new range become half, 3.5. Interquartile range become half, also divided by 2. And mean also divided by 2. But variance is not divided by 2, it's divided by 4. So you get 1.34. And standard deviation, the new one, is divided by 2, is 1.1576. So the conclusion is, when each of the set of data is divided by a constant k, then the new range is equal to original range divided by k. Okay, the new interquartile range is original interquartile range divided by k, and new standard deviation is original standard deviation divided by k, but new variance is original variance divided by k square. Last but not least, please remember divided by k is equal to multiply by 1 over k. Okay, what are the effects on the measure of dispersion when an outlier is added or removed from the set of data? For range, it will change dramatically when an outlier is added or removed from the set of data. For interquartile range, is less affected when an outlier is added or removed from the set of data. For variance and standard deviation, will increase significantly when an outlier is added into the set of data if the difference between the new value of the data and the mean is small. Then the new standard deviation will be smaller, and vice versa. Okay, if the difference between the value that is removed and the mean is small, then the new standard deviation will be larger, and vice versa. Let's see the example here. Given a set of data 4, 6, 7, 7, 9, 11, 12, and 12. Calculate the standard deviation of the set of data. Hence, calculate the new standard deviation when 4 is removed, 7 is added, and 18 is added. So I will discuss further for this example. Let's follow my lesson now. So the conclusion is, when the value that has a greater difference from mean is removed, the new standard deviation will be smaller. For this one, when the value that is close to the mean is added, the new standard deviation will be smaller. When the value that has a greater difference from mean is added, the new standard deviation will be larger. So, student, we have come to the end of the class. So, this is the homework for today. There are 6 questions for you. Please try it on your own and then send your homework to my Gmail account. Okay, thank you. Have a nice day. Hi student, keep on practice your maths. Okay, if you practice every day, your result will be flying color, just like the rainbow here. Okay, bye. Have a nice day. Practice your maths.